Welcome back. So in order to start this second hour, I would like to show you a few things and ask you a question. So let me go to it. So first, I wanted to show you that there is this homepage with the language that we are looking at. And if you click, so you have a beginner's tutorial, that's just yet another piece of material. I think the TAs took a bit from there. You have a specification of JSONic that is accessible, looks like this. It's much more detailed than what you see in the tutorial, but it can be a reference if you're interested. There is also some Rumble Sandbox online that everybody can use. You don't even need any installation for that. Just be aware that this is running in machines with one single core and 1 GB of memory, so it's really just to play with. But you notice because it uses this public rumbledb.org access, right? Now, when you use the Docker, Docker Compose environment that we have, it's running directly on your machine. But this is basically the idea. And you can also, this is a very, very large tutorial that you have here also. You also have, I already told you, a JSON validator that you can use. It's also running on the same servers, also runs on your own machine with localhost. Just put JSON validator.html. You also have, this is if you don't want the notebook, you can also type a query here and execute it, get the results on the right. But again, maybe Jupyter notebooks are easier to do this. Do I move this? Yes, exactly, then that's the spec. That's the web page of MongoDB, of RumbleDB with the download. By the way, you can also download a very big jar and execute it as a Java program. Then you don't even need any Docker environment. So some people also like to do this. You can just use it as a command line, you know, execute a query on the command line and so on. Okay, but what I wanted to ask you is this. So I'm curious because we had discussions just last week with other lecturers at ETH and with the rector. Out of interest, I would like to know, have you already been using generative AI with the course material, any of you? So you might be in the following situations. First, maybe you never used generative AI in the context of this course, but you did use it in studying, maybe for other courses, I mean, ChatGPT and so on. Or maybe you have never used generative AI in the context of studying at all, ever. You've never done that. Or maybe you tried to just connect to ChatGPT without a subscription or equivalent, Bard or I don't know, and then asked about the course material. Or maybe some of you might have taken a subscription to one of these and asked about the course material. And some others might have tried, this was one of the new features announced, of creating your own GPT, like configuring it as a virtual assistant or as a virtual student, uploaded the big data textbook, and then ask questions against it. So I wanted to see where we stand. We do seem to have a majority here. So it seems that most of you just connected there and asked questions about the course material. By the way, I'm interested if you have screenshots of that, of what you did, you can send them our way to the TA team and so on, just so that we see the kind of things that you're doing. I'm interested. There is a minority of you. Do we have anybody in the room that actually did create a GPT uploading the textbook? 1, 2, yes, awesome. And 3, here you are. I did too. I tried to just put the textbook in there. It actually works. So it's great. I mean, this is the future. It's going to be supporting us. Of course, you need to be aware that it can make mistakes. I think there's even a big warning at the bottom of the window that says this. But I just wanted to make sure that everybody is basically aware that this is the sort of things you can do. If you've never done it, you might not know about this. But I just wanted to make sure that you know that it can actually help you. Now, yes, yes, go ahead.
The way how you write the book, especially with the reflection questions, actually help GPT to also formulate questions, because this is, for example, one of the things I used it for. That I split up the book into chapters, uploaded it, and then asked it to please ask me regarding the reflection question, and those things actually can nail quite well.
Oh, that's very nice to know. Yeah. So basically, just to repeat for those on Zoom, you were saying that the reflection questions like, do you know this, do you know that, right, in the chapters, they guided ChatGPT.
They guided ChatGPT, ask it to basically assess you based on these questions.
Ah, so you ask, yeah. Maybe you can speak in the microphone to share over there, because the people on Zoom can also hear you. This is very interesting experience for everybody.
So the thing is, using ChatGPT even before they opened up this build your own GPT, like at the beginning of the course, I tried to use just snippets of the documents and upload them, and then use that as a form of self-assessment where you can tell it to use the learn objective or reflection questions to then ask it to please ask you regarding these, and then just assess how well you are. And it seems to work quite well.
Mm-hmm. That's nice to hear. So you basically created assessments so that it creates questions for you, that it tests your knowledge, or you
more like an independent party that uses the questions you have created as a way to assess yourself, because as an external assessor.
Okay, yeah, awesome. No, this is great to hear. Any other experience that some of you would like to share? Right. Okay. So thank you for sharing this. And so I just wanted you to know that everybody is on. Oh, yes, go ahead. Maybe we can also send the microphone your way.
Yeah, I also use the GPT tool. So I built a GPT, and I think it works really well. It's sort of like a binary tree. So whenever I do an exercise, I can say, recap me this concept, and then I can ask more questions to go deeper. And it's much faster than reading through the whole notes.
Yeah, so it helps you in this way, like to get faster through the notes.
Yeah, and for me, there was not really many problems with hallucination. I just say to stick to the knowledge as much as possible.
Ah, that's good to know. So it didn't make so many mistakes.
Yeah.
How is it for you? Did it make mistakes? Or anybody else who tried it? Did it make many mistakes in your case? Did it make mistakes, the GPT?
Basically, I wrote my own answers to the questions, and I just asked please check if they are conform to the stuff in the
to the stuff in the Would you be able to share screenshots? I mean, if you want, of course, right? I would be very interested. Yeah. Okay. Yeah. So we can take it offline, and you can share. So yes, thank you very much for sharing. Thank you. And so yes, you can try it out. We don't know, it's just the beginning. We don't really know yet how things will evolve, but it's probably here to stay. I like to compare this to the invention of calculators and the way that it modified teaching mathematics. Okay, but this is very good for me to know. If necessary, I can share. I will be able to share with you some screenshots of what I did, or even maybe the exact configuration of what I did. I did something plain and simple. And if someone to try it out, then you can. All right. So again, be careful. It can make mistakes. Do not treat it as a virtual TA. Treat it as a virtual student, right? Who might make mistakes and so on, but that you interact with and who might explain you things in a way, right? Yes?
Also, what was really useful to use in the course, what was actually effective, not useful, what was actually quite effective in the course to use was GitHub Copilot as well. Like whenever I was doing the Jupyter notebooks, because you can use them, you can do them in an ID of your kind, VS Code or PyCharm or whatever. I was seeing that Copilot even managed to answer the theoretical questions, and they were 90–95% correct at the time.
Wow, this is very
so
interesting.
Copilot was more correctly than ChatGPT in many cases.
Okay, so GitHub Copilot.
Yeah,
it's basically another one. Okay, yeah, thank you for sharing this. I actually tried back then, I think a few months ago, I tried to ask ChatGPT to write JSONic, and it actually could write JSONic. I don't know where it learned it, but it did learn it. Go ahead.
So I have a question for you to see how lecturers think about it. Do you ever plan on, like, would you ever decide on letting students use Copilot or ChatGPT during an exam?
These are but this is
not
serious.
now.
This is a serious question. Yeah, and in fact, I've had discussions about that. So we have exchanges. There is a team at ETH called LET, which basically looks into the technologies to support teaching. And these are things that we're openly discussing. Like, would it make sense that we say you have an exam. It's not going to happen this semester, right? This semester is it's going to be closed. But in general, these are things that we're open about. Like, could we, for example, imagine that you're open to the internet? You can use search engines. You can connect to ChatGPT and ask. We have to think about what it means for how to formulate the exam questions, because of course that would need to be done differently. It would probably target a lot of the critical thinking, like, because if you go through these kind of tools, the burden that we didn't expect from you is the verification. You get an answer, and then how do you verify it? Which is technically how it will work later, right? If you use it on the workplace or in life, you have to verify what it's telling you. And so that would be testing more in that direction. Yeah. But so yes, we are having these discussions. I cannot tell if or when it's going to happen, but these are discussions we have. Yeah. All right. Yes, another remark over there. Yeah, maybe several hubs. Yeah.
Oh, you really want that?
Ooh, be careful, be careful. Oh, wow, very impressive.
I was keeper in my football team. So for me, it's mainly really useful to give me examples to the lecture. For example, today during the lecture, I was just talking to GPT. For example, I didn't understand something about range indexes or want to have more concrete examples, and I can just interact directly and ask kind of here questions. And where I can see it really promising is in combination with the Whisper API. For example, we built in the last hackathon a tool where you can upload the video link, for example, from the video portal, for example, lecture of yours, and it would generate a transcript, put the transcript in chunks to GPT, and then you can kind of ask questions directly to the video, and it would also generate you questions to assess you. And so that's a thing which I find really, really useful to just kind of have a conversation basically with a lecture video.
This is nice. So you basically took the YouTube recordings, got the transcripts, and uploaded them to ChatGPT.
Exactly. So that we get the transcript with Whisper, and then put the whole transcript. Sometimes it's too long for like a 1 hour, 2 hour lectures. We chunk it and feed that into GPT to ask then questions directly to the video and generate summaries or LaTeX summaries.
Could you send us a link to the tool just so we share also with everybody, just so?
It's a little bit expensive still, the Whisper API to like generate transcripts directly
from videos.
But the code itself, how it works, I can definitely share.
Yeah, that would be nice.
Without my API key.
Okay, of course.
Yeah.
Yes, we have another comments here. Yeah.
Before again, in an examination context, are we allowed to use documentation, for example, to look at Spark docs or something like that?
So it's a closed exam, meaning that you cannot bring anything. However, you have the Jupyter notebooks, and then you can use, so for example, there's a calculator in Python. You can type any calculations you want. Python has some documentation. You can use the Python help. We give an example in the cheat sheet. So you cannot bring additional documents. However, if you would like to, if you think that some more examples in the cheat sheet would actually help you, that we can add, we still have time because the cheat sheet now is not finalized. So we can add if you have specific aspects of the language that you would like to have. If you would like more documentations, like, I don't know, some PDF or something, we could try to look with the LED team if they would allow us to add some PDFs in there. I'm open to it, basically, but it has to be the same for everybody. You cannot bring extra material just for yourself.
Yeah, no, I meant like the official Spark docs.
The official Spark docs.
I mean, I use that for a lot of the exercises that we have to do in quizzes.
So we could see if we manage to export it as a PDF or something. We'll investigate. Maybe the TA team can look into it. You can send us a link to the exact page that you refer to. I mean, everybody can give us IDs, right? Whatever helps you for the exam, because you're going to have to write queries with PySpark or Spark SQL and JSONX. So we want to make sure that you're supported. Yes?
Regarding the exam,
Thank you. Regarding the exam again, because you said the cheat sheet, when will we see the cheat sheet? Or do we have, or is there any place we could have a look at it to see what's already on it?
Yes, we do give it to you before the exam. You know exactly what there is going to be. We even have these Docker Compose environments that has the past exams. All we'll do is add the new one to that environment. So you'll know beforehand, you'll know the data sets, we'll tell you which data sets you are going to have. And this is all open.
Thanks.
All right, thank you. All right, so let's keep the conversation going. You can also use the Moodle forum, of course, if you want to discuss more. But thank you very much for this. I learned about what you're doing, and it's very interesting to know the sort of things you'll be doing, and maybe for others that gives you ideas on what you can do. All right, so now I'm going to switch back to my slides. I need to, I think, stop sharing and then go back to the slides. All right, and where did I, oh, yeah, here it is. All right, so yeah, these are special times, basically, you know, when I went to school, so it was basically in the 90s that I was in high school. And back then, what was going on is that computers were starting to appear. And it was a situation that was strange because the students knew computers more than some teachers. And now we are in a situation that I guess that some of you master ChatGPT much better than we do. So we are trying to, you know, to follow you and adapt and think about how it impacts the teaching. But these are really exciting times in terms of where this is going. And I heard, I mean, I don't know if you watch the news, but apparently some people managed to also create an equivalent, like an AI, not to do languages, but to do math at the grade school level. So I don't know much about what's happening. It's not public, but we'll see the progress that it makes. All right, I think it's Q star something. It's called Q star, I think, yeah. But we'll see if they tell us more about that. All right, so now let's get back to JSONic. So the idea is that this RumbleDB that we developed here at ETH is able to read data from many different places, from your local drive, even without the Docker Compose environment, from the web, directly downloaded from the web, on HDFS, on S3, on Azure, and so on. So you can read from many different data lakes. You can also read in many formats. You can open JSON documents. CSV also works. It's just going to give you flat strings. Avro, Parquet, binary formats, they also work. You get sequences of items. Root is used by the particle physicists at CERN to spot the Higgs boson. There is also a paper to read if you're interested about the topic as an optional material. LibSVM is for machine learning people. And even text. You can really open text documents with RumbleDB. And manipulate it, right? Then you just get sequences of strings, and then you can even build an information retrieval index for those of you who attended information retrieval. All of with this, right? So many formats in different storage systems. And the view of this is, whoever heard about the word lakehouse? Some of you. That was suggested in 2021 in the CIDR conference as an extension of the notion of data lake, but with an integrated warehouse in the data lake. So everything in there, meaning that it's a data lake, but not just to read, but also to write back data to the data lake, to have machine learning on top and so on. And so that's one of the directions in which a lot of people are going now. And the vision is that JSONic can also be used on top of data lakes. In fact, it's not released yet, but I had a student, David, who implemented just this year, actually, an update extension to RumbleDB to actually write things back to the lakehouse, right? So I don't know where it's going to be released because we need to prepare it for the release, but it will come at some point. And there is also a machine learning extension. It's not part of the lecture, but there is a machine learning library in RumbleDB that directly allows you to run high-level machine learning predictions on top of the data. But again, not in the scope of the lecture. All right, so these are all the people that I'm thankful to for contributing, and maybe some of you in the future will continue this adventure. So what is JSONic really? It's a data calculator, right? It's just a fancy calculator. For example, 1 + 1 gives you 2, and that works. That is JSONic, 1 + 1. Then you can also try more complex arithmetic. If you looked at the tutorial, you saw how this all works. So it has addition, multiplication, division, and so on. You can do comparison, smaller than, greater than, equal, and so on. Then it returns Booleans, of course. Shouldn't surprise any computer scientists. Then we can bind variables. You've also seen that in the tutorials, that using the let variable. Be careful, the let variable is a binding, it's not an assignment, right? It might not be obvious if you just look at a simple query like this, but in a functional language, like even if I'm thinking of Haskell, F#, OCaml, and so on, almost all of these have let clauses where you bind a variable. And here it basically means, give me $i + 1, knowing that $i equals 2. That's how you should read this query. And then it gives you 3, of course, right? You can also have, this is why it's cool as a calculator, because you can calculate JSON, not just numbers, JSON. So if you copy-paste JSON, objects, arrays, anything, copy-paste it, it will return itself. So if you give an array like this, it just returns the same array. You can do it with objects, with any JSON value you want, right? You can, an object as well. And then you can also apply more operations, just like you can have addition, multiplication on numbers. You can have dots to navigate objects. So in that case, you have an object foo1 dot foo gives you back the 1, right? So it's fully composable. It's just like arithmetic, except that it involves JSON objects. All right, you can do the same with arrays. For example, you build an array 3, 4, 5, and these double square brackets basically means you're accessing the position in the array, so the first position. We are reasonable people. We start counting at 1 in JSONic, right? It's actually a W3C standard, 95%, called X query. And so we just start counting at 1. So do not be surprised if you used in other languages, they start at 0. So this is why I get back this 3. For whom is that intuitive, this and this, right? That in the same query, you build an object, copy paste, and then followed by navigation. Who finds it intuitive? Right? Awesome, perfect. So it's just a bit calculator. This is something more complex, where you have this object, dot foo gives me the array 3, 4, 5. Double square bracket 1 accesses the 3, and plus 3 gives me 6, right? That's just a more complex query. I told you it's a Lego game. Just like you put multiplication, addition, and so on, you can just compose in any way you want. If you have a doubt about the precedence, because you know that for numbers, multiplication has precedence over addition, it's also the case for this, but it's impossible to know all of that by heart. So if you have a doubt, just put parentheses. It's just going to shield you from any ambiguity in the code. But what's fancy about that calculator, and I gave you a hint of that, I think, at the end of the second tutorial, is that all of these return one value, right? It's one array, one object, one number. But look at what happens here. I'm returning 3 numbers, 3, 4, and 5. It's not an array. It's really 3 numbers. And what happened here? I created an object. I access the dot foo, gives me this, and then this pops this open. It opens the array, unboxes it, and I just find a 3, a 4, and a 5. This here is called a sequence. It's a sequence of items. I told you I'm going to say that 200 times. So this is a sequence of items. In that case, it's a sequence of 3 items. The first item is a 3, it's an integer. The second item is a 4, and the third item is a 5. And the power of JSONic is that you can have billions, if not trillions of items in the same sequence. Of course, not on your laptop. That would be on a cluster. But you can actually have enormous sequences of items. You can actually very easily create these sequences with this. The 2, for example, 1 to 4 gives you that. And in fact, you can even try 1 to 1,000,000 on your laptop if you want to try. Normally, RumbleDB is going to automatically create it in parallel, magically. It's not going to iterate. It's literally partitioning and putting it all over the course. So you can actually go ahead and write 1 to 1,000,000. Here's another one, which involves the for loop. So this I introduced just in the tutorial this week. The for loop is just iterating over a sequence. like that, not an array, a sequence. So here I have this sequence 3 to 5 give me 3, 4, and 5. And what happens is that I bind $I to each one of these items in turn. So the first time I'm going to be binding $I to 3. The second time I'm going to be binding $I to 4. And the third time I'm going to be binding $I to 5. And each one of these times, I create that object, but replacing $I with what it's bound to. And I get this right here. Yes, there is a question.
Everything that evaluates to a sequence is then iterable. From a previous example, that you could also put a for loop on top of that. With
anything that is a sequence, you can put in a for loop. So you can replace this 3 to 5 with absolutely anything you want. And if it's not a sequence, I mean, it's always a sequence, but if it's a sequence of just one item, then it's just going to do it just once.
Is the for loop also executed in parallel?
This one? This one?
Yeah.
Yeah. So in that case, it's not going by RumbleDB, it's not going to be executed in parallel because RumbleDB sees that it's only 3 values. So it's not going to bother because that would create an overhead. However, if you do put 1 to 1,000,000, RumbleDB is going to smartly figure out that it's better off doing it in parallel, and it's automatically going to spread it over the course of your machine.
To generate the sequence or to execute the for loop?
Both. It's going to generate the sequence in parallel in a smart way. Then the sequence is in your memory, and then it's going to create, it's actually going to be using Spark. So it's going to be automatically over the course of your machine, generating these objects back in parallel threads. Yeah, thank you. And you need to think about this in 2 levels. There is the logical level. In the logical level of the language, you don't care about parallelism. Parallelism is not part of the language. Even if there's a billion or even a quadrillion items in there, all the language says is for every one of these quadrillion items, we're going to create an object like that, and that's the output. Now, there's the implementation of this, which in that case for RumbleDB is done on top of Spark. Maybe in 10 years, there's going to be a new cool engine that we can re-implement everything on that's going to be even faster. But this is then a physical implementation detail. So you can do as a mental exercise, ask yourself, could I do it in parallel? But keep in mind that this is already an implementation detail when you think of that. In order to learn the JSONic language, you don't need to think in parallel. You can just think purely mathematically and logically, this is the sequence that I'm generating and manipulating. But if you think on top of that, also already ahead of how is that implemented, how can I parallelize, even better. And I'm going to tell you a few words about that, right? Does it make sense? Awesome. So in that case, it's 3, and it's going to be executing this 3 times, which each one of the values of $I, and I get this. By the way, it figures out that this is an integer. It has to be a string. It's automatically going to cast it back to a string to get a key here. So there's extra mechanisms in here. All right. Now I can also put any sequence in there. I could put this instead, right? That now is going to also iterate. But I will also show you examples like this with entire collections and data sets that you can iterate. Oh, here's one actually. I already have one right here. So what I'm doing here is I have an S3. I stored on Amazon S3 some directory with plenty of JSON lines files, 1 object per line. And I can actually directly use this JSON file function. So function, I put a path, possibly with a star, that tells everything in that directory. This here is going to iterate on every JSON object, on every line of text that you find in this file. So every JSON object, and it's going to output the object itself. Here it's redundant because actually I wouldn't even need the for return in the first place because it's just the identity, right? But you could imagine instead of $I that you have something more fancy than $I, right? But basically, if there are 1 trillion JSON objects in these files, in this directory, then I'm going to be getting from the for return part, this is going to return. So this returns a billion objects, then it iterates on it and again recreates the billion objects. And I wrap that up, it's a Lego game. So I put that all in another function called keys. Keys takes a sequence and outputs the unique keys. This is great for discovering a schema. Somebody give you a data set that has terabytes of data, drop it to HDFS or S3, put a query like that, you will know over the cluster using the Amazon cluster it's going to give you quite quickly the unique keys that they are. And now you know these objects, they have the keys foo and bar. Maybe some of them have only one of them or none, but these are all the unique keys that they are in the data set. What is important to understand is that keys takes a sequence of items, a sequence of objects. If there are things that are not objects, it just ignores them. So a sequence of objects there. But the magic is that you can have 1 trillion objects in there, or you can have 10. It's all the same for JSONic. Doesn't matter how many there are. If it's just 10, it's just going to be executed locally. If it's a billion, it's going to spread it all over the cluster. But that's the beauty of data independence, because when you look at the language, you don't care. It's all isolating you from the details of the implementation. So then you feed that into keys and get this schema. Now, I told you that the first thing you should do if you're about to query a data set in JSON is to convert it to a Parquet file. It's possible to, in fact, do it also with RumbleDB. I will say a few words about this later. But if you already have the Parquet file created, then you can also use the Parquet file function in order to access them. The results will be the same, but it's going to be faster. And do you remember why it's going to be faster with Parquet? Because it's compressed. Parquet stores it as a data frame. It's not going to repeat the keys because they're always the same keys. It has a schema, and this is much, much, much faster. It will be able to project away and ignore all of the keys that it doesn't need. In that case, it needs them all, actually. But let me now think. So this is the logical level, right? On the logical level, it's the same results. Think physically, how quickly do you think that query is going to execute? Who thinks it's going to be slightly faster than this one? Who thinks it's going to be incredibly fast like O of 1? In fact, you're correct. It is literally O of 1. And do you know why? Does anybody know why I'm getting that in almost O of 1? Yes? Yes, O of 1 in the sense of with billions, it feels like O of 1. It's going to be as many as there are files, basically. Yes, more precisely. Can you give a more precise answer? Almost. Can you maybe try? Do you have an idea? Yes, exactly. You're correct, indeed. So basically, the Parquet files, they do have a schema. At the beginning of the Parquet file, you have a schema, and then you have all of the encoded and compressed objects. So basically, to answer this query, all you need to do is open the beginning of the Parquet files, get the keys from the schema, and return them. You don't even need to bother looking at the data. This is the magic, and RumbleDB figures it out. This is, again, the beauty of data independence. You see, the query is exactly the same one, but the implementation is going to be different. It just will be faster. Any other questions so far? Yeah, go ahead.
So basically, RumbleDB is able to figure out how you're going to use the results of this object, of this query or whatever, and optimize based on that.
Yes, RumbleDB basically in that case notices that it's the keys function that you're using on top of that, so it's going to figure it out. If it had not been the keys function, then it would have accessed the data.
If you were to store it in another variable, for example, or object.
Yes, exactly.
And then on the next line, just use keys.
Yeah.
It still do the same optimization.
Yes. Yeah, it will also figure it out. Even if you put that in a variable, the for return, and then use keys on the variable, that will also work. And I'm going to give you an intuition of that as we go through the language, right? First, I'm teaching you the language. Then I'm going to explain to you the implementation of how this is done. It looks like magic, right? There is this saying that any sufficiently advanced piece of technology is indistinguishable from magic. But you will see that there's no magic. There is a way that makes it work, and that's actually based on Spark. Okay. Now there's a whole ecosystem of languages, but again, I'm teaching you JSONic. It was one of the very first one. What's happening now is that people keep discovering that we need languages, but instead of reusing the ones that exist, they reinvent a new one. So every company now invents their own language. I hope it's going to consolidate back into a single language like SQL. That would be my hope for the future. But again, if you know JSONic, you will have absolutely no difficulty learning any other of these languages. All right, so what's the data model? Not surprisingly, it's based on JSON. So you have objects, arrays, strings, numbers, booleans, nulls. That's all part of the models. These are possible items. Then any expression returns a sequence of items. The sequence of items can even be heterogeneous. You could return a sequence with a million items, and in there you have objects, you have arrays, you have integers, you have dates, you have binary values, and so on. So it can be heterogeneous. That's the power. That's not like SQL. In SQL, you can only return tables, collections of records that all have the same schema. But here you can be heterogeneous. That can be a sequence of any values you want, completely mixed. It's denormalized because that sequence could contain arrays and objects. And within the arrays and objects, you might have nested arrays and objects with no limit on the depth. So it's fully denormalized. That's why it helps. Now, what's important to understand is that sequences are flat. It means that a single item is the same as a sequence of one item. We basically identify the two, right? If I say one item or if I say a sequence of one item, that is the same thing. If I try to compose sequences in that way, like concatenate them, it's always flat. You will not create any depth or nesting doing that. If you use a sequence, comma, another sequence, it's always flattening everything. The only way to get nestedness is with arrays, right? But the sequences, they are only on the outer level and they're always flat. And this is why we can have billions or trillions of items in a sequence. In an array, no, you cannot have trillions in an array. But in a sequence, you can have trillions of items. There is a special sequence called the empty sequence. It's a sequence of 0 items, right? And that can be returned by an expression. It's just nothing. There is absolutely nothing in there. What can the items be? They can be atomic values, booleans, dates, hex binary, strings, and so on. They can be objects, they can be arrays, or they can be functions. But I'm not going to scare you with that because that's called higher order functions. So we don't have that. Functions are also part of the standard. In fact, they're super useful for machine learning because functions are how you could store machine learning models and estimators and so on. But this is completely out of scope of the lecture. If you're interested, you can go to the documentation and look for Rumble ML, but I'm not talking about functions in that lecture. So just atomic objects and arrays. And basically, every expression in JSONic returns a sequence of items. So you're going to return sometimes, to give you a few examples, an empty sequence, or a sequence of just one item, in that case a string, or a sequence of integers, or a sequence of booleans, or a sequence of objects that look alike, or a sequence of arrays of integers but of different sizes, or a completely heterogeneous sequence. So you see that it's a whole spectrum from super highly structured here to super denormalized and completely unstructured. You can have a huge mess in there. It's entirely possible. And in the middle of that, you probably notice something that looks and feels like a relational table. Who sees that? Right. This is basically a superset of the relational model because the relational model can just be implemented as flat JSON objects that all have the same values and types. So here go the relational tables, but we can also do that SQL cannot. And we can also do this that SQL cannot. Right. So that's the power of it. And now we just build the Lego game looking at all the fancy things you can do with JSONic. I'm obviously not going to be done today, so I'll continue tomorrow. But basically, to explain to you, JSON doc opens a JSON file that has a single JSON object, but over multiple lines. You will sometimes find that over the internet, right? A configuration file or something, a single object over multiple lines. Then it's not the same thing as JSON lines. JSON lines would be one object per line. So let's open that single object. So I get a sequence of one item that is an object. Then I add dot countries. So in that case, countries is an array. So I get a sequence of one array in that case. What if I add this unboxing, so the double square brackets, I unbox the array into a sequence of how many items? 5. So this is a sequence of 5 objects. Now dot name gives me a sequence of 5 strings, right? These are the ones that I illustrate in there. I could do code instead and so on. So you see how it works. Then I can also use predicates. This is a filtering predicate. where I'm just giving a criterion here, and I just want to have the $$ is whatever I'm looking at, one by one. I just want to select the objects so that when I do dot codes, when I look at the code field, I find CH. So this is going to pass. This is fading, 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 fading. So the only one that survived is this because code is CH. And again, the $$ is just the current item. You're going to iterate over all of the items. And every time you take the current item, test for this. If it's true, you keep it. If it's false, you reject it. In fact, it's a Spark filter transformation, as you might guess behind. Or a where with a select from where if it's with data frames, that I'll tell you more soon. And then you can continue because again, it's a Lego game. So now that I have picked the one with code CH, .name gives me Switzerland. So that's a sequence of one string Switzerland. Who understands this query? All right, awesome. So you see, it's quite intuitive to do. Now, if I don't use JSON doc with a single object, but now JSON file with trillions of objects. So here is countries. So there's not trillions of countries. There's only 200 or so. But if I do that, I can actually have one object per line, and then I filter $$ code equals CH. That gives me the first object, and .name gives me Switzerland. That is an example now on a data set. And this is working on data sets of any sizes. So now I have, this is just more geeky, because I'm showing you actual output from my screen. You can actually try it even yourself. So I just have the command. So this is when I run it in a shell. So it's not using Jupyter Notebooks. You can also run with the Java jar. If you download it, you only need Java. And then you can use the Java jar command to run a shell. And then you can type your query, twice enter, and you see the results. So here I type a query that just returns a sequence of how many items? In that case, 36,000 items, because this is just what I put in that file on the web. It exists. You can really try it. I do have a file at that position that has this, and you can do it. It will download it from the web, open it, and extract the items. Now, obviously, it's too much for the screen, so I cap at 200 items. RumbleDB will only output the first 200 ones. You can change that value, of course, on the command line if you're not happy with it. This is just to avoid crashing your machine if there are too many of them. But it will tell you the counts if it can figure it out, so just that you know the size of the sequence. And now I can do things like using the single bracket with a number. So the double bracket is the position in an array. The single square bracket is the position in a sequence. So with this square bracket 1, I'm just asking for the first object in my sequence, the first item. It would be like a select star from limit 1, basically. So I just pick the first one. So I get this object. Now you can see what it looks like on your screen. Then I can use this keys function with my data set. And now you see, I get 8 different keys. And now I know that that data set has these 8 keys, right? So it's called schema discovery when you do that sort of thing. But you see how short the query is in order to do that. You cannot do it with SQL because SQL assumes you have a schema already, right? And here I'm opening just JSON. I can also navigate dot type. Dot type is just going to be applied to every object. So for each file, I go within this and get the type value. Now I see there's some redundancy here. So what are all the unique values of the type key? I just add these distinct values call around it. It's like a Lego game. And now I get a smaller list with all the unique values in there. You see, with this, I can analyze my data set and get an impression of the keys that they are in there, the unique values that they are in there, like this. It's all happening nicely in parallel over the data. Just a word of warning, here is the web. The web is obviously not HDFS, right? So I just use the web as an example. In practice, you're going to be using S3 or HDFS to really get some parallelism. All right, I think I should stop here, but you already have an overview. So tomorrow, I'm just going to continue and get you through JSONic, show you all the things that it's able to do, and we'll just make as much progress as we can tomorrow. There will be JSONic at the exam, and I really encourage you to use all of the notebooks we give you and the tutorials and so on to become familiar with it. Thank you very much, everybody. I'll see you tomorrow at 9. Thank you.